Bismillahirrahmanirrahim. Assalamu alaikum. This is Raja Omar on my channel RU Speaks, as Raja Omar speaks for you for the subjects of Pakistan studies and global perspectives. And these days we are discussing the component 2 of Pakistan studies, that is the environment of Pakistan, the geography portion, and we are discussing the unit power sources, and we have already discussed the hydroelectric power and thermal power, and we have already discussed the fossil fuels like coal, gas and oil over here, that how they are extracted, from where they are extracted, and what are the uses of those fossil fuels in the power production process. And we have already discussed that how the hydroelectric power and thermal power are generated and what is the importance of them. We are going to talk about the nuclear power now. That is our next topic, and here we will discuss the production process. And you can see that Pakistan is a nuclear power, and we have the nuclear energy resources available with us. And what are the key features of this nuclear power in Pakistan? Base load, that is that it provides consistent reliable power to us, as the we have sufficient nuclear fuel available, and that is uranium. Industrial reliability, critical for stable industrial operations, as the energy which is produced through nuclear means, that is quite consistent and it provides the energy in sufficient amount. Key plants: Chashma nuclear power plant, and now we have 4 power plants over there at Chashma district Miawali, and they are known as Chashnup, CHASHNUPP, Chashma Nuclear Power Project 1, 2, 3 and 4. So it means that there are 4 nuclear reactors producing power over there at Chashma. And you know that there is the Chashma barrage over there very close to, and you know that in the process of making nuclear power, there is the need of a lot of water. So the water is taken from river Indus. There should be the consistent water supply as well for carrying out the process of the nuclear power generation. So the other one and the older one, that is the Karachi nuclear power complex, that is what we call CANUP, Karachi nuclear power plant. And it is a sort of test case in the beginning. At Pakistan started producing the power through nuclear means first at CANUP, and Pakistan found that whether Pakistan will be able to generate more power from nuclear means or not. And when Pakistan became successful in producing power through nuclear means at CANUP, that was only 37 megawatts of electricity. That was almost nothing whenever we talk about the power generation, but that test case proved successful. And then Pakistan moved to Chashma, and where 4 nuclear power plants are installed. They are producing quite a lot of energy for us now, and 400 megawatts each power plant is producing. So 4 fours are 16, so it means that 1600 megawatts of electricity is being generated through nuclear means in Pakistan at Chashma. So nuclear energy supplies crucial base load power, ensuring industrial reliability. These plants provide consistent energy, minimizing power fluctuations, critical for heavy industries. The Chashma and Karachi complexes are pivotal to Pakistan's energy security and energy resources. Now, energy through nuclear fission reaction, and this is the actual process what we call the nuclear fission, through which the uranium atom is broken down into barium and krypton and releasing a lot of energy in the process. That is what we call the nuclear fission reaction. And nuclear fission is a process in which the nucleus of a heavy atom such as uranium-235, this is the atomic mass of uranium, or plutonium-239, splits into 2 smaller nuclei when it absorbs a neutron, or when it is hit by a neutron at the nucleus of the bigger atom like uranium, it breaks down into two smaller atoms in barium and krypton, and a lot of energy is released. This splitting releases a large amount of energy in the form of heat, along with more neutrons that can trigger further fission reaction. A chain reaction starts. In power generation, this heat is used to produce steam, which drives turbines connected to electricity generators in nuclear power plants. So if you see over here in this diagram now, this is the uranium 235 atom, and here we are going to strike a neutron, and when this neutron hits the nucleus of uranium, this uranium atom breaks down into barium 92, and krypton 92, and barium 141, the atomic masses, and a lot of energy is released over here, and 3 neutrons evolve out of this process, and these 3 neutrons further strike 3 more uranium atoms, and breaking them up again into krypton and barium, and again a lot of energy is released, with releasing 3 neutrons from each breaking down of the uranium atom, and in this way the chain reaction starts from 1 neutron to 3, and from 3 to 9, 9 to 27, 27 to 81, and so on. But you know that in this way the energy is uncontrollable, what we call the nuclear bomb. So what is done during producing energy over here, that the energy is taken under control due to certain measures. They use the heavy water, and they also use the cadmium rods to absorb the excessive neutrons, and the heavy water decreases the speed of the neutron. We will discuss on the next slide. So here is the nuclear energy structural diagram. If you see over here, here is the actual nuclear fuel over here in this container, and you can see that there are the uranium rods as well, and there are the control rods as well. The control rods are mostly cadmium, and cadmium absorbs the excessive neutrons. As you know that if we control the number of neutrons, we will have the energy in controlled form that can be really very effective. Otherwise it will be disastrous. And here we have the heavy water over there, what we call the deuterium oxide, D2O, and neutron is let me change the color, as the color of water is also blue over there. Let me change the color of the pointer. So the neutron is allowed to strike uranium over here, and uranium atom breaks down, releasing 3 atoms, but maybe 1 or 2 neutrons might be absorbed by these cadmium rods, the control rods, and only 1 strikes neutron remains that may strike the other uranium atom to break it down. So in this way, whole of this chamber would get hot because of that released heat energy out of the process of breaking down of the uranium atom, and water would be heated up, and that hot water will come over here, and it will convert into steam over here, and that steam would move these turbines in this chamber, and after that the steam will come to this chamber over here, and this is condenser. The steam is condensed and converted into water again, and the water pumps are installed over here to supply the water again back to the same chamber for the sake of using it again and again. In this process, definitely because of the severe heat, the water evaporates, and because of the evaporation of that water, we need a lot of water more in the form of supply, and we are supplying that water from here. And here is the cool water basin, cooling tower, and here we have the non-radioactive water vapors which are coming through after getting the energy over here, released energy from the condenser. And when these turbines move, they produce the mechanical energy, and then mechanical energy is transformed into the electrical energy over here in the electric generator, and then the transformers, and then the transmission lines. So it means that the electricity goes into the national grid. So this is whole of the process. Again, you can see that again a refresher for you. Let me erase everything and then to explain the thing again, so that nothing should be left unlearned. So what is the actual process? Actual process is the heating up of the water through the heat produced after the breaking of the uranium atom. So here we have two sorts of rods. Number one rods, they are the uranium rods, and the other ones, they are the control rods. They are installed over here. Because of the strike of the neutron, the uranium atom breaks down, and three neutrons, they evolve out of that process, as I told you in the previous slide. And one or two might be absorbed by these control rods, and only one remains which strikes the other uranium atom to produce heat. So because of that heat, you can see that this whole of the chamber is shown as red. It means that because of the heat, the water has got quite hot, and this hot water comes over here, and it turns into steam because of the severe heat, and this steam moves these turbines, and the mechanical energy is produced over here, and that mechanical energy is converted into the electrical energy, and that electrical energy is actually the power, and that is transmitted through transmitters and the transmission lines over here. And the steam goes to the condenser after rotating those turbines, and gets condensed over here and turns into water again, and that water is again supplied to the main chamber where the nuclear process is going on. This is whole of the process of the nuclear reactor. This is what we call the structural diagram. Now, pros and cons of the nuclear energy, that what are the benefits and what are the drawbacks of using nuclear energy. First, the pros: reliable and consistent supply. We get provides uninterrupted electricity, high energy output, small fuel amount produces large amount of electricity. So it means that small quantity of the nuclear fuel can produce huge amount of energy. So this reduces fuel imports, as we are importing a lot of furnace oil and gas and coal to import, and importing it for the sake of generating power in the thermal power stations. If we are able to generate more power through nuclear means, we will be saving a lot of foreign exchange for us. So low emissions, emits almost no greenhouse gases during the operation. So it means that the pollution factor is nowhere. So it means that if you are producing electricity through nuclear means, you are protecting your environment as well. Space efficient, it can be installed in a smaller place, and it does not need such a huge place, just like the hydroelectric power stations, like big dams consuming hundreds of thousands of acres of land to construct one big hydroelectric power station. I mean, the dam requires less land than the solar or wind farms. Even if we want to produce more energy through solar and wind farms, we have to install many hundreds of solar panels and many wind turbines on the larger area. So in comparison with those as well, along with the hydroelectric power stations, nuclear power stations consume really very less land. So all these are the plus points. Now talking about the cons, that is the negatives, that how this power can be really very negative for us. High costs, expensive to build and maintain nuclear power plants. So as it is the very specific and complex form of electricity production process. So it costs a lot to maintain the nuclear power stations in working. Radioactive waste, as you know that uranium is or plutonium is used as nuclear fuel over here. So uh, whatever the waste comes out of after producing that electricity, still that waste has certain radioactive radiations. They are dangerous for human beings. So the disposal of that waste is a big issue. Produces hazardous waste needing long-term storage. So it means that the how and those the waste of the nuclear fuel, I mean whether uranium or plutonium, can be disposed of. That is the issue. Risk of accidents, nuclear disasters can be catastrophic. I mean, if God forbid, if there is some blast in the nuclear power station, just like, I mean, if the nuclear fission reaction gets uncontrollable, then what would happen? That would be really very much disastrous. God forbid, it would be very much like Hiroshima and Nagasaki. So limited uranium as the nuclear fuel is not available in abundance in Pakistan, and at times it is needed to be imported. So it means that it becomes really very expensive form of fuel, and at times because of the global restrictions we may not be able to import that fuel. So it means that if the fuel is not available, definitely we will not be able to run the nuclear power stations. So security risk. Nuclear material can be misused or stolen somehow, and that can be very dangerous. I mean, but this may not happen in Pakistan, as we know that Pakistan's nuclear sites are under full security and under control, so no risk of that. So now talking about the solar and wind energy, the rising renewables, as slowly and gradually the Pakistani population, people and the government wants to move towards the renewable form of energy, and these two are one of them. So solar power growth, Pakistan has 4.9 gigawatts net metered solar capacity. Key sites include Punjab, Sindh rooftops, and Qaid-e-Azam Solar Park at Bahawalpur in Cholistan Desert. So, wind power potential, approximately 1.7 gigawatts of wind power potential power is installed. The Sindh wind corridor, Jampir and Garo facing the Arabian Sea, in those areas the wind power potential is quite a lot and is significant resources for Pakistan. Solar and wind energy are rapidly expanding in Pakistan. Solar energy with its net metered capacity supports both utility scale and rooftop installations. The Sindh wind corridor offers immense potential for large scale wind energy projects. So it is needed that we should be working on these projects to have more energy resources available for us, so that we may be able to overcome the energy crisis in Pakistan. So here we have the diagrams, solar and wind energy, the structural diagrams. Here we have the solar diagram, that is as it is installed at homes. Here you can see the sun, then solar array, I mean these solar plates are installed over here, what we call the solar panels, and then DC current, it comes to the inverter, into the charge controller, that is the DV box, it is also known as the circuit breakers, and they control the charge, and from that the DC current that is goes to the inverter, and from inverter to it goes to the the DC current is converted into AC, alternative current, and that AC current goes to the equipment to lit up the house and to run all the electric appliances. And if the solar panels are producing sufficient electricity, that can be stored in the battery over here as well. But this is what we call the hybrid system. In the hybrid system, that the energy is produced and that is also consumed over here in the electric appliances, and that is also stored in the battery as well. So it means that this DC current is stored over here in the battery, and AC current is consumed by the electric appliances. That is what we call the hybrid system. But in many areas of Pakistan, the people who have installed the solar panels on their rooftops, they are not using battery, but they are using the on-grid inverters, and whatever the electricity they are producing over here, whether they are consuming it or they are putting that solar power into the national grid, they are giving that energy to others through their solar panels. So that is the structural diagram of the solar energy. Now talking about the wind energy, that how the wind turbines they work. And on the right hand side of my screen you can see the diagram showing the structural diagram of wind power. So rotor blades, we are having the cross sectional diagram of the wind turbine, and here are the blades and they are rotating like this, and wind direction is coming from here and these blades are rotating and they are known as the rotor blades. So here we have the gearbox at the back end, and then here we have the nacelle and what we call the generator installed over here, and whole of the structure is known as nacelle. And here we have the power cables coming down within this structure, the column or tower. And here we have the transformer over here. The basic things which are needed, number one, we can say turbine, right? In any of the power production process except solar, the major factor is turbine. So over here these blades are working as turbine, and the second very important the constituent of the whole of the process, that is known as generator, and the third one is known as the transformer, right? So they are the basic necessities of installing any of the power process. We have talked about these ones in the hydroelectric power generation as well, and we have talked about in the thermal power stations as well. We have talked about in the nuclear power stations as well, and here we are also talking about the same in the solar power generation. So turbine, generator and transformer, so these things are must in every power generation process. So the cabling is coming over here, and then we have the grid or the transmission lines, and the electricity is supplied to the national grid to be consumed by the people. So this is how the structural diagram, and I believe that this is not really very much difficult to understand. So moving on, that is the solar power pros and cons. I mean, if we talk about the solar energy, what are the positives and negatives of it? So positives: renewable energy, no harm to the environment, sunlight is abundant and will not run out. So it means that it is the long lasting energy. You will be having the sunlight available all the time as sun is there. So environmentally friendly, no pollution or greenhouse gas emissions. So it means that it is really very important, and it is not harming any of the environment. So pollution free, ideal for remote areas, those areas which are far away from the national grid and they do not have the electricity supply connections over there, or the transmission lines are not available over there. So in those areas the solar panels can be really very effective. So low operating cost, if you first install the solar panels, and then the operational cost would be really very lower and your electricity bill would be really very less. After setup, maintenance costs are really very low, and even the operational cost is really very low. Reduces electricity bills. You will be having you will be saving your money with paying almost no or really very less electricity bills. So that would be a plus point for the installation of solar power to you. So now the cons, that is the negatives. High initial cost, you need a lot of money to install the solar panels. For example, if you are installing about 10 kilowatts of solar panels over there on your rooftop, you might be spending about 1.3 million rupees these days, and that would be a big expense. And this 1.3 million rupees are without battery. If you install batteries, then the cost may rise up to 1.7 million. So High initial cost. Installation of solar panels is quite expensive. Weather dependent, as you know that today we have the cloudy weather over here in Rawalpindi, and my solar panels, they are not producing much power today, as if and we are using ACs right now, and those ACs are consuming the electricity supplied to us by the housing society. So it means that we are bearing the bill right now, as there is no sunshine at this time. Less effective on cloudy days or during winter. Requires large area, needs a lot of space for solar farms or panels if they are installed by the government on larger areas to produce huge amount of electricity. They require a lot of land. So energy storage needed. Batteries are required for use at night, so batteries are really very expensive, so that is a sort of burden over there on the finances, uh, and it is really very difficult to bear that cost, as those lithium batteries are tabular batteries are very expensive. So for a single house, if there is the you can say 10 kilowatt solar panels are installed over there, then you need about 10 to 12 batteries to store that energy produced by those solar panels, and that over expense is on you after every 2 to 3 years, as the batteries would get drained off. So that is not a good decision to install batteries. So low efficiency conversion of sunlight to electricity is not 100%, and whenever you say that you have installed a 10 kilowatt solar structure over there, definitely you will not be getting the 10 kilowatt of full electricity, but that might be of about 7.5 or 8 kilowatts of electricity. So the efficiency is not good one, I mean about 75 to 80%. Now the wind power pros and cons. Pros of wind power: again, it is renewable resource. Wind would be blowing all the time, and you would be having that energy all the time with you. It is unlimited. It is clean energy and no harm to the environment, pollution free. So no damage to the air or water. So suitable for coastal areas where there is a lot of wind blowing all the time, and that energy can be produced in abundance over there in on the Sindh coast and even on the Makran coast, Balochistan. Low running cost, minimum maintenance after installation. So reduces fossil fuels use, as we import a lot of fossil fuel to run our thermal power stations. If we install the wind turbines over there, the import of fossil fuels would minimize. That would be saving of the foreign exchange. So now the drawbacks: inconsistent supply. Wind does not blow consistently or continuously, so that would be a fluctuation in the power supply. High initial investment. Wind turbines are costly to install, so it would take a lot of money to install many power wind turbines over there on the coastal areas. Noise and visual pollution. Turbines are noisy and can spoil the scenery. I mean, that is a sort of we might be having the deforestation to install all those wind turbines over there, so that would spoil the scenery of some area. Harm to wildlife. Turbines can affect birds and local ecosystem. The birds might be dying because of the striking the blades of the wind turbines. That would be harm to the ecosystem. Needs open space, large area needed to set up the wind farms. So we may not be having such area available. So it means that we would not be able to generate enough power. So now I want to wind up the whole of the lesson today. And biomass, biogas, and geothermal emerging solutions. I mean, these are the future prospects of Pakistan towards the power generation. Organic waste, agricultural residues and organic waste serves as the primary feedstock for generating biofuel. And digester conversion. Waste undergoes anaerobic digestion to produce biogas, so that is the second process. And gas, heat or electricity. Biogas is then utilized for heat, electricity or direct fuel. So it means that here are the methods we can use. I mean, biomass biomass is just like the waste of the plants, like the husk of sugar cane, and that is consumed in the sugar industry. The most of the sugar factories in Pakistan, they have installed their own uh, power plants, and they are consuming the biomass, I mean the husk of that sugarcane, the crush or the waste of sugarcane. After extracting the juice out of that, they are consuming that husk in the what we call the bagasse. That bagasse is consumed as the fuel in the power generation process, and the gas is also extracted out of them from the animal waste. And geothermal, when the coal gasification is done underneath, the long bore and deep bore is done, and certain chemical processes are done underneath wherever the coal mines are. That is known as the geothermal. I mean, to get the heat of the earth, to heat up the water, and to convert that water into steam, and that steam can be used to move the turbines and then generator and transformers. These emerging energy resources offer localized and sustainable solutions. Bagasse from sugar mills and biogas plants are prevalent in Punjab and Sindh's agricultural belts. Geothermal pilot projects are also being explored in northern Pakistan, but not really very effective much, and we have not get any good results out of that. So economic impact of the powering Pakistan's industrial future, as we know that we are growing in on the industrial grounds and we need power a lot. So energy availability, consistent power directly correlates with industrial output and employment, boosting textile and other sectors of Pakistan. Energy deficits cost 2 to 4% of GDP annually. So it means that we are facing deficit loss just because of the less power supply availability. Otherwise, the economy might be having 2 to 4% more in GDP if we have sufficient power sources available. Cost competitiveness, affordable energy reduces manufacturing production cost. Hydroelectricity's low cost is a strategic advantage for steel, cement, and chemical industries. I mean, if we focus more on the hydel power, the power through water, that can be effective in reducing the cost of production of the products, very especially the steel, cement, and chemical industry products. So in this way, that would be more beneficial for Pakistan's economy, that we might be producing the low cost products and we might be having the competitiveness in the international market regarding the production of those products. Investment and growth. If we would be having the sufficient power availability, definitely the industry would grow and people would invest in the industrial sector, and Pakistan would move towards industrialization. Reliable power attracts foreign direct investment, FDI, and the foreign investment investors, they would come over here. They will bring their investment over here and they will install their industries, as they might be having the fact with them that Pakistan have sufficient power availability in industrial zones, including CPEC special economic zones. They are really very important, and the foreign investment would come over there on the CPEC projects. And over $30 billion invested in CPEC energy projects, and we might be having the benefits of all those products somehow up to 2030. So hope for the best. Job creation, the employment, energy infrastructure projects and industrial expansion creates millions of jobs. The power sector directly employs over 150,000 people. So if we are having more and more power generation plants through all these means, definitely that would lead to the more employment over there in the power projects. And also when the industry would develop, people might be getting a lot of jobs over there in the industrial sector, so the unemployment would decline. Then export investment enhancement, when more industrial production would be, definitely the impact would come on the exports of Pakistan, and then we would be having the export oriented industries over here in Pakistan, and Pakistan's foreign exchange would increase to a greater extent, and the country's economy would boost. Challenges for sustainability. that what sort of challenges we are facing regarding the sustainability of the power sources in Pakistan. Circular debt, over $10 billion in circular debts hampers new investment and operational efficiency. It affects fuel procurement and sector liquidity severely. So I mean that the uh, burden of loans on the government regarding paying the fuel cost to the private thermal power stations, that is becoming a big burden on the government. That $10 billion are to be paid to those private power producers, so that they might be able to produce and more power by importing more fuel. But if the government is not able to pay those fuel bills to the power producers, they would stop producing and the things would lead to the load shedding. So import reliance, over dependence on imported fossil fuels like oil, LNG and coal causes price volatility. This strains foreign exchange reserves considerably, and government has to pay a lot of import bill in the form of the import of the fossil fuels to run those thermal power stations. What happens eventually, that the fluctuation of prices in the international market of all those fossil fuels like oil, coal and gas, the electricity prices increase to a greater extent within the country, and the people are unable to bear their electricity bills. So it means that we are relying more on the fossil fuels import. So if we explore more and more fossil fuels within the country, we will be able to having more availability of that fuel within Pakistan, reducing the cost of production, and we will be able to saving our foreign exchange as well. Grid integration, integrating variable renewable energy into the national grid. I mean connecting these solar power, wind power stations and all those into the national grid, so that more and more power should be generated and should be available for the people, rather than wasting the energy and wasting the resources to us. So losses, high transmission and distribution losses, 17 to 18% energy is lost in the process of transmission, and due to the outdated infrastructure and theft. As you know that the national grid is really very old, and with the help of those old equipments, the electricity losses are quite high, and even the electricity theft is quite high in Pakistan, and people are stealing the electricity and they are not paying the full bills, whatever the energy or the power they are consuming. This costs Pakistan over rupees 300 billion annually. So that is a big loss for Pakistan, that because of the line losses, the loss of electricity during the transmission process, and because of the theft, these two are causing 300 billion rupees to Pakistan. So climate vulnerability, hydropower is highly susceptible to climate change. As you know that we are having less rainfalls, and our dams are not having sufficient water availability to generate more hydroelectric power. In the same way, we are facing the climate change impacts on the solar power, as well as the solar energy is getting lower, and in the same way the wind power. So glaciers melt and changing monsoon patterns impact water availability directly. That is the vulnerability of the climate related to the hydroelectric power stations. So energy efficiency, low energy efficiency industrial and domestic sectors lead to higher demand and waste, as the industry is also outdated and industry consumes a lot of energy, and the machinery is outdated. That outdated machinery consumes a lot of energy, leading to more and more demands of the energy, and that energy is not available, leading to the pressure on the industrial production, the power production sector. So sustainability goals target 60% renewable and hydel by 2030. Let's see, if we are having the Amir Basha Dam, what would the impact come over there on the power sector of Pakistan. So now the conclusion, just winding up, sustainable foundation we need, that is we are supposed to move towards the hydro electricity and renewable power productions like solar and wind, and then necessary reforms modernize the grid and prioritize the distributed renewables, reduce subsidies and circular debts to minimize the burden on the economy. So future prosperity, sustainable energy ensures export competitiveness, job creation, and economic resilience, leading to the development. So embracing hydro electric and renewable energy sources is paramount for Pakistan's long-term industrialization and economic growth. Strategic reforms, including grid modernization and a focus on distributed renewables, will be crucial. A sustainable energy future is essential for global competitiveness and a resilient economy to prosper and to move forward. So, connect with me for more and more resources of IGCSE Global Perspectives and Pakistan Studies. My email addresses are over here. One is a personal one and other one is of my YouTube channel ru.speaks@gmail.com, and second one is rajaumar75@gmail.com. My contact numbers 33357 tetra 51 and 30657 tetra 51, and my social media platforms, that is my YouTube channel ru_speaks, Raja Umar speaks for you for these subjects. Signing off. Thank you so much for watching. Allah Hafiz.